كدمي عيني لوي النابلكي ليتي بحلمي إنات ملسكي دحي مدرخ سنكي أبمع بالحامسي كالسي وتيو هيوتون كالسي وتون كالسي يا
Hello, how are you? I'm Azahir Selassie and I'm mathematics teacher and also mathematics tutor. So today we'll continue for the second subtitle, what we call continuity of a function on intervals. In the last part, as you know, we have seen continuity of a function on a point or at any number. So under the intervals, we have different types of intervals: closed interval, half closed interval, half open interval, bounded below interval, and open. And this is bounded above interval, and the same is true. This one is closed, but this one is open. Again, from the picture, what I want to translate, or what the meaning of for this picture with this, or what is the relation between this picture and with this one, or in the intervals instance. We have here a cat and a rat. The rat is under a cup prism, which contains a circle. So it is closed. So the cat cannot attack the rat, but simply it can be seen. So the life of the rat is continuous. So the life of the rat is continuous till the circle is finished, or it will finish a lot of days, so it might be die. So by this mean that the closed interval a and b in sense, which means that it is closed under what you call under the cup prism, and she has its own food, so it can be survive for a lot of days, beginning from A to B. Such expression is called closed interval instance. Again, if so, can conclude from this real life example the continuity of a function on interval instance. So this is the life of the rat is continuous over the closed interval a and b, So we'll continue to this real life word problem or concept expression, how to it could be related with different examples. So we will see for each of these examples an interval can exist in either of one of these intervals. So it shall be practiced using the example. So today we are going to be check whether a function is continuous on intervals. So let's see one by one. A function is said to be, a function f of x is said to be continuous at a closed interval a and b if it's continuous for every point in the interval including the endpoints a and b, which means that the function should be defined for every element of the interval, including the endpoints instance. Which means that if you are going to be say continuous, it should be defined, the limit should be exist, and the limit will be at functional value. Let's say now we'll see example. F of x equals to 1 over x plus 3. Continuous is the function continuous in this interval, to close the interval minus 3 up to 9, which is no, because it's not continuous for every, it is continuous for every point on the interval, but it is not continuous at minus 3 itself, because it's not defined. No? If you substitute minus 3, this gives, if you evaluate at minus 3, then 1 over minus 3 plus 3 is 1 over 0, which is not as we have in the last week. 1 over 0, which is not defined. But it is works for every point. Except minus 3. That's why we are going to check it at minus 3. It violates the rule, so it is not continuous. Let's see the remark. While we'll check continuity of a function on whatever interval, finding the domain of a function is very important to decide the continuity, which means that the domain of the given function, which is f of x 1 over x plus 3, its domain is or real number except minus 3. But I am asking the continuity, the closer interval from minus 3 up to 9. But minus 3 is excluded from the domain. That is what you have to be aware of this one always. So normally it is okay. Checking continuity instance, indirectly you have to be calculate the domain of the function. If you know very well the domain of the function, it's not a problem to check what you call whether it is continuous or not. So if you look for this function 1 over x plus 3, its domain is or real number except minus 3, but I'm asking at minus, including minus 3. So at that time you are going to be say not continuous, because at minus 3 not defined. It is not defined. Second, a function is said to be continuous on the open interval at open interval AB if it is continuous for every point in the interval except the endpoints. We don't bother to check at A and B. Why? Because this is open interval, which means that exclude A and B. No matter to check. It's not obligatory, or it's not must to check A and B. Why? Because this is open interval. But if it is closed, you are going to be checked at the endpoints. Know the difference now. Having this definition, let's repeat it, the above example itself. I have make now the closed interval into open interval. Now, is f of x equals to 1 over x plus 3 continuous on the open interval minus 3 up to 9? Yes, because it is continuous for every point for the given open interval. No need to check at the end point of minus 3 and 9. Well, because its domain is or real number except minus 3, but minus 3 is excluded here, so no need of to check at minus 3, but for every number it is continuous, it is defined, so it is continuous. Another example, third, I think this is the third example, sorry. A function, or the third definition, a function f of x is said to be continuous on the interval or bounded below, in a sense. Yes, bounded below. If it is continuous for every point in the interval, including the endpoint A. including point A or the number A. Are going to, this is must check whether the function is defined. So let's see this example. This example talks or gives what you call for the function f of x is a function f of x equals to log of into x minus for continuous in the closed interval minus for up to above or unbounded, which means that from ground plus 4 up to sky instance, unbounded, the above one is unknown. That's starting from ground plus 4, assume like that. So no, because it is not continuous, because it is continuous for every point on the interval, but it is not continuous at 4, which means that if you evaluate at 4, why? Because this is obligatory. It is obligatory to check at number 4 itself. At number 4 itself. If we check at number 4, insert it. Now, whether it is defined or not in instance. If you substitute instead of x 4, then 4 minus 4 is 0. Log 0 is undefined. Log 0 is undefined. So if it is undefined at 4, it is not continuous over the interval. Again, let's continue to the exam definition 4. A function f of x is said to be continuous on the given interval open or excluding a instance. Excluding a. Be careful, please. Don't confuse with these symbols. They are sensitive. I think it is clear what I want to be explained here. This interval is a is included, which is closed interval, but this one is open interval. Which means that the difference, we are going to check for the above, including a, but here is excluding. Let's check it itself, the example. Is f of x equals to log into x minus for continuous on open interval for up to infinity? Yes, because it is continuous for every point on the interval except 4. Why? Because this bracket has an information or tells you don't include number 4, or don't be checked at number 4 itself, but for the above it is must check at minus 4. You have to be insert into the function. At that time, while you insert the function, then it gives log 0, but it's not must here. Smoothly, it works. It's defined. At the same time, it is continuous. Definition 5. Still, we are going to deal in the what you call the definition for continuity or checking continuity on intervals. So we have different form of intervals. So this is what you call a function f of x said to be continuous on the interval, closed interval a, but b is open. If it is continuous for every point in the interval, including the endpoint a, but not at b. We don't care about b, but we are going to be aware about a. So let's check for the example which satisfies for this definition. That's why is f of x equals to 1 over x minus 7 continuous on the interval minus 7 up to 7? Yes, because it is continuous for every point on the interval except at 7 itself. It is not must to check for 7, because if you include 7 minus 7 is 1 over 0, which is not defined, but it's not obligatory to substitute 7 into this one. Why? Because it is open interval. Now we have to be mind, please, guys. We have different forms of interval. If you have to be exclude the endpoint of or the endpoint or a number or like this. Look, if I have a comma b, this called open interval. So no need of to check at the endpoints. If it is closed, you have to be check both of them. Like in this example 5, such intervals are called half interval in a sense, half open, half closed, half open. So which tells you check at A but no matter at B. You have to be check whether the given function is defined at A but no matter at B. Yes, so you have to be differentiate different examples